quick recap on this. Basically, this is not a new rule. It's not going to be a new rule. It's the same techniques you did before. Okay, so you need to expect any technique from before. So here, it's basically an integration with a problem. There's a problem happening. Okay. Now we have two types of problems. So, something we call type 1, type 2. Type 1, basically, one of the bounds, at least one of the bounds, is plus or minus infinity. Okay, so I have integration from 1 to infinity, 1 over 1 plus x squared dx. We call this a type 1 improper integration. Okay? And then we have type 2, which talks about, which has its continuity problem. Discontinuity problem at one of the bounds or in between. What does that mean? If I have integration 1 over x minus 3 dx, where is this function discontinuous? At which point? 3. I plug 3, I get division by 0, which is not defined. Okay? So let's say I wanted to integrate this function from -1 to 3. But 3, I have a discontinuity. So we need to deal with this. Okay? We need to try to work this out. So we need to try to work this out, yeah? Good? So let's take examples. Here I'm not introducing a new technique. It's the same techniques that we did before. By substitution, by parts, partial fraction, trig integration, anything you want. But here you need to account for this type of problems. You have infinity or minus infinity. And you need to account for a discontinuity. Right? To fix this, we're just gonna use some notation, that's it. Like we're just gonna write the same thing, the integration answer, in a specific notation. Okay? So let's take example. Let's take something simple to start with the idea. Let's do the first one. 1 to infinity, 1 divided by 1 plus x squared dx. Okay? So forget about the integration bounds. Yeah? If I give you this integration without the bounds, do you know how to integrate this? You should be able to. Okay? I'm expecting you to be able to integrate this. So this is what? Anyone knows? Tan inverse. It's basic integration, right? So this is going to be tan inverse. Okay, of x. And then I need to plug the bounds, right? So I put 1, and then I put infinity. But that's wrong. If you do this, this is wrong. So the problem is at infinity. So what do? We replace it with t. We replace it with t. And then you take a limit. As t goes to infinity, you have to write it exactly like this. Okay? You replace the problem with t, and you take a limit all the time. Okay? Alright, now from calculus 1, how do I do this? I plug the top minus, forget about the limit. Plug the top minus plug the bottom, right? So this is going to be what? Limit t goes to infinity, tan inverse of t minus tan inverse of 1. Yeah? How do I solve any limit? Substitute. What do you get? Tan inverse of infinity, right? Minus tan inverse of 1. What's tan inverse of infinity? Does anyone know?
Pi over 2.
Yeah, how do you, let's say you forgot in the exam, how do you prove it? You have a nice tool called calculator, you can use it.
You can.
Yeah? You can use it. Give me any calculator and then put tan inverse and then put like a very big number, 1, 0, 0, keep going. It will give you a pi over. Okay? And again, tan, of course in radians you put it. And tan inverse of 1 is pi over 4 from the calculator, right? So this is pi over 4. Clear? Yeah? So that's it. Okay? So this is just to introduce the idea properly. Okay? Now let's do harder examples. Let's do something hard. Okay? Let's do this one.
So, when do we change the both? Do we change the both boundaries?
To t you mean?
Like any T اللي تحتها. Do we?
No, you don't change both. You only change the one that has an issue.
Okay.
The issue here in type 1 is what? One of the bounds is infinity, so you change that to t.
Okay.
T is continuity. Where is this continuity of this function? At 3.
3, right.
So 3 you make it t.
Okay.
Makes sense? Only that. One bound. Okay? So let's take something hard. Let's do a to infinity 1 over x minus 7 power 3 over 2. Okay, let's do this. This is nice. So first, which type is this? Type 1 or type 2?
1.
Type 1. You need to have eyes to just answer this question, right? This is type 1. Clearly I have an infinity. Okay? Type. Let's say now, forget about the integration itself and the bounds and everything. If I give you this function, how do you integrate it? Going back to the previous sections. So if I give you 1 over x minus 7, 3 over 2. How do you do this? Does
Power
anyone
rule.
know?
Power.
You can use power rule. Yeah, how do you do that? X minus 7, negative 3 over 2, dx. I'm allowed to do power rule here, why? Because it's a linear function. If it's not linear, I cannot. Okay? So now, how do I integrate now? Add 1 and divide by the new power, right? From where to where? From 8 to t. 8 to t. Okay? And then I take the limit. As t goes to infinity. Okay? Now, forget about the limit. Plug the bounds first. Okay? So limit t goes to infinity. Okay, this is divided by negative half, it's negative 2. T minus 7, negative half. And then minus is plus. Plug 8. Good? Now you can plug the limit if you want. Okay? So how do we do this? This is minus 2. This is what? Like, I don't know what's this exactly. It's power negative half, so I can put it down. 1 over t minus 7 power half. This is 2 times 1 is 2. And then again limit as t goes to infinity. Yeah? Now what? Plug the limit again. 1 over infinity minus 7 is infinity. Root of infinity is infinity. So 1 over infinity is what? 0. So this goes to 0. So the answer is 2.
So what happens to the minus half?
This is 1 power minus half, right?
Yeah.
1 power anything is?
1.
So? Okay. Okay. Notation. We say that this question of this integral is convergent. What does that mean?
It's not infinite.
Convergent means a finite number. So I have 2 types of answers. I have convergence and I have divergence. Divergence when you have plus infinity, minus infinity, or like any form of oscillation. It's like sine infinity. You don't know what sine infinity is. It does not exist. It diverges. You say it diverges. And convergence when I have any finite real number. Positive, negative, zero, fraction, I don't care. It's a number. Yeah? So that's the idea, because we're gonna talk about these too much. Okay? So our goal in this section would be to determine if an integration converges or diverges. Okay? So let's do more examples on this. So here, I want you just to forget about the bounds. Now, which type is this? Type 1 or type 2? What do you think?
Type 1.
Type 1, clearly, it has infinity. Type 2. Okay? There is no discontinuity here. Because its continuity happens where? At 0. 0 is not in the bounds already, so we're good. Okay? Now, okay, so if I give you this integration, forget about the 81, it's not just outside. If I give you this integration, how would you solve it?
Substitution.
Use substitution, yeah? Use substitution. So what do I take u as? Yes, function and its derivative. Yeah, so u is ln x, and du is
1 over x.
x dx. So this becomes integration. Ln x is u, 1 over x dx is du. That's it. Now, the 1 and infinity are for which variable? For x. For x. So can I use them for u? No, I cannot, so I have to change them, right? How do you change them? Through the relation between u and the x. This is the only relation that you have, right? So if x equal 1, where did I get this from? Here. Then u equals what? Ln of 1, which is 0. If x equal infinity, u equal ln of infinity. What's ln of infinity? What's ln of infinity?
Infinity.
Infinity. Right? So 0. Yeah? And then what? Integrate. How do you integrate? U. What does it become?
U squared over 2.
I replace the problem with t, and then I take the limit as t goes to infinity. So this is equal to what? Limit as t goes to infinity of t squared over 2 minus 0 squared over 2. This is 0. Plug infinity. Infinity squared over 2 is infinity. Therefore,
It's divergent.
yes, and t equal.
So in the exam we should do this.
Should do what?
The integral is divergent specified.
Well, if they ask you, specify. Yeah, I'm doing this for you, but it's better to, just in case. I don't know, like the grade and what he thinks. Okay. Okay. Let's do more. Let's do this one. You notice I forgot about the 81.
But it doesn't matter.
It doesn't matter, it's infinity anyways. Okay, it's fine. Okay. Let's do. Not like this. Let's do this one. type is this?
2.
Why is it type 2?
But not infinite.
Not really. What's tan? What's tan from school? What's tan? Tan.
Sine of cos.
Sine over cos. So why does this integration have a problem? Let's see.
Cosine.
So notice that cosine square of pi over 2 is 0. Yeah?
Yeah.
So here I have a discontinuity at this round. I have a discontinuity.
So it's the second type.
It's type 2. Yeah? Because I have a discontinuity at this point. Good? Alright. Again, we forget about improper, we forget about everything. I focus on integrating tan squared. How do you integrate tan squared?
Minus 6, right?
What?
1 minus 6, right?
Yeah, we never integrate tan squared, right? We integrate its formula, which is secant squared minus 1. These are basic integration rules, but sometimes they're confusing. Okay? What was it? Secant squared minus 1. Again, forget about the balance formula. Secant squared becomes tan, and 1 becomes x. From 0 to pi over 2? No?
You change
No?
T.
T. The problem is T. The problem is pi over 2. So what do? You replace it with T? Yeah? And limit as T goes to?
Pi over 2.
Pi over 2.
Okay. Now,
Do we always put T, or if it's continuous, you just put the other number?
yeah, if it's continuous, you just put the other one. But here it's not continuous, right? So you have to replace it with T. So if you do this, this is wrong. Why? Because in limits, specifically when you talk about numbers, I have to pick, is it from the right or the left? So who can tell me? Can someone see it or no? Why is it from the left? Look at my interval. 0 to pi over 2. Yalla. Kindergarten math. 0 to pi over 2, right? This is in the interval. Okay, this is my interval, right? Does my interval contain pi over 2 from the left or the right?
Left.
Left. This is pi over 2 from the left. This is pi over 2 from the right. This is the one in my interval, so I put the left. Clear? And then I plug the bounds and then take the limit. So limit as t goes to pi over 2 from the left, like this, tan t minus t, plug the top minus plug the bottom, tan 0 minus 0. Yeah, tan 0 is 0, this side is all 0, so we're good. Okay? Now plug pi over 2, so tan pi over 2, this is suspicious here, so you put from the left, minus pi over 2. Can someone tell me what's tan pi over 2 from the left? You don't have to know, use your calculator. How do you do that? Yalla. What's pi over 2 from the left? Like what number do I put here? I want you to plug tan inverse, tan of pi over 2
3.
minus 0.00001 as much as you can. Isn't this pi over 2 from the left? Just taking it a step back, right? How much is this number? Yeah, someone tell me.
100,000.
Yeah, that's good. So where is this going?
It's
Infinity. Positive, right? Or negative?
Positive.
Positive. Clear? So this is positive infinity. Minus pi over 2, who cares? It's positive infinity. So this integral is divergent. Any questions? Here?
After you integrate, what happens to the secant square?
Yeah, what's the integration of secant square? Stand. These are the basic rules.
Yeah.
Integration of 1 is x. So that's it. Okay? Okay, let's do more. Let's do more. Need more space.
Professor, can you explain how you got infinity?
From where? For
Uh,
tan inverse? For tan?
Yes,
Here?
0.001.
You mean this one?
Yes,
Plug it on your calculator. Did you try it?
yes, without negative
Show.
positive 0.027.
When you put it in maintenance, you have to do reasons. This is pi. See? This is pi. So, should we do one more? Let's do one more. Let's do this. I hope I remember correctly. This one. Okay? Type 1 or type 2 and why?
I do.
Why?
Because it has discontinuity in E.
E. If you plug E, then E is what? 1. Calculator if you forgot. 1 minus 1 0, so I have discontinuity. So we have discontinuity here. Okay, so this is gonna be replaced with T, right? Yeah? Or no? This is the problem. The problem is here. So I replace it with T in the end. I mean, this is where we take the limit. Okay, forget about the bounds now. If I give you this integration, how do you do it? Okay, what? Is this a basic integration? Like, can I answer right away? No, so I have to use techniques. Substitution, bypass, partial fraction, blah, blah, blah. Okay? What's this? Substitution. I can see a function with its derivative. No?
Right.
U equals
Next is 1 over x.
so 1 over x dx is du. This becomes integration of what? Du 1 over root u, and I can change the bounds. If x equal e, then u equals 0. How did I know this? I plugged here. If x equal e squared, u equals 1. So this is going to be 0 to 1. Okay? Still the problem is here, right? If you plug, it's clearly discontinuous here. So this is the problem. I'm going to replace it with t. How do you integrate 1 over the u? Does anyone 1 over root u? How do you do that? Power.
Raise it
Power
to the
half,
top.
raise it up, do power over. So let's do that. It's u negative half du 0 to 1, which is u half over half from. Now you put
T.
t
1.
to 1. And then limit t goes to 0 from the right or the left? Why? Because our interval, yalla baby math, 0 to 1.
Right.
This is my interval. Does it contain 0 from the right or the left?
Right.
0 from the right. Make sense or no?
Yes.
It doesn't need any high IQ here. Please. Okay, now what? Let's plug the bounds. T goes to 0 plus 2 minus, right, this goes up, minus 2 t power half, yeah? Then plug 0, what do you get? 2 minus 2, 0 power half, just 2. So this integral is convergent. Any questions? Yeah? So now we go to another topic which is called comparison tests. Comparison theory, whatever you want to call it. Okay? Which basically tells you that I want to evaluate this integration. Now what's wrong with this? What's the problem here? The problem here is that no integration technique works. No integration technique works. You can try it yourself. I cannot do substitution, I cannot do by parts. I cannot do anything. No trick substitution, nothing works out. Yeah? Because you know most of the functions in math can be integrated anyways. So what do we do here? So it's gonna be a trade-off here. I'm not gonna integrate, yes, but at least I want to know if I converge or diverge. This is the most important information. Okay? But again, it's a trade-off. Since you did not integrate, even if you converge, you wouldn't know what's the number. Here we converge to 2, right? But if I answer this question, it will converge, but I wouldn't know to what number. It's a trade-off.
You have to compare it to another function.
You have to compare it to something you know already. Okay? So we have to compare. So we compare to what they define in class as P integral. You took this, right? Or you didn't? You did.
Yeah.
Integration 1 to infinity 1 over x power p. Now this is not necessarily 1, by the way. There is nothing special about it. A, and A is any number strictly larger than 0. Doesn't matter. Okay? So this has two answers. This will converge if p is larger than 1, and this will diverge if p is less than or equal to 1. So this is called the p integral. Yeah? So how do we compare? How to compare? I want to use basically inequalities. Inequalities. It's like squeeze theorem in a way. Calculus 1. What did we do in squeeze theorem, for example? We used to say sine and cosine are between what and what?
Minus 7.
You have to know this.
Yeah.
You have to know that sine square and cosine square between 0 and 1. You have to know that tan inverse is between minus pi over 2 to pi over 2. Yeah? And you have to know some pure facts. What does that mean? Pure facts. Based on logic, nothing else. It's like saying 1 plus x squared is larger than or equal x squared. Isn't that a fact? I came and told you this. It's a true statement. Okay? So these are the tools that we need to solve these kind of integrations. Okay? So let's do examples. Let's do examples. There's also one more. Len x is less than or equal x power a, where a is any number larger than 0 of your choice. It's fine, anything. Usually we use 1. Okay? Okay, so let's start. Let's do questions here. So, they will tell you use the comparison test to determine if it converges or diverges. Example. Use the comparison test to determine if the integral converges or diverges. Okay, so let's start with something basic. Okay. Okay. So now, how do I solve this question? We're going to do it in 2 steps. Okay? One procedure in my head, I'm going to do it. And then the other procedure is using inequalities. Okay? So, in your head, I want you to take the leading terms. What are the leading terms? You understand what I mean by leading terms? Or no? The terms that have the highest degree. Okay? So what's the leading term on the numerator?
Squared.
Numerator?
On the numerator.
4. 4. It's like, who's closer to infinity? Cosine is always between -1 and 1, it oscillates. And 4 is 4. It's above that, right? So I pick 4. Yeah? But what's the leading term in the denominator? I'm not asking a tough question. What's wrong? Sure.
X squared. The x.
X4.
4, yeah, but it's under
X4.
root.
The highest degree. You know how to. You know 4 is larger than 2, right?
Yeah.
طيب, what's wrong?
No, it's under the root.
Okay, under the root. Give the root. What does this become then? 4 over x squared from 1 to infinity, right?
Yes.
Does this converge or diverge? From here. Why? What's p? P is 2. Right?
Yeah.
So this must converge.
Converge because bigger than 1.
Yes. I don't answer like this. This is, in a way, garbage, okay? But it will lead you to the answer. Okay? It will lead you to the answer. So you know what to expect. You know the answer by looking. Okay? Now, fine. Let's write proper math and construct the answer. Okay? Now, I'm gonna ask you a question. 4 plus cosine x root x4 plus x squared. Now, I need to use inequalities, right? I need to use inequalities. But should I do larger or less? And why? Why? Exactly. So convergent mean what?
Because
A number. A number. If I chose this, and I said it's larger than 4 over x squared, this is convergent, right? For example.
Yes.
But can I say anything about this? What does larger than convergent mean? Larger than 5, let's say. Convergent, let's say 5. Replace with a number. Larger than 5 could be what? 6,
7.
7, 8, or infinity. So this could converge or diverge, right? And I don't like this. We don't need two answers of the inequality. We need one answer. So this selection of the inequality is wrong. Since I converge, I need to make it less than finite number is finite. Make sense or no? I'm just using pure comparison between numbers. Yeah? So what, do you understand that I need to make it less here? So less than or equal. Yeah? It has to be something here. Something that looks like this. Something that looks like this. Okay. Alright. So now when I compare a fraction to a fraction, yeah? I want, since this is larger than this, then I want to make this maximize. And I want to make this minimum.
We can remove the x squared.
Yeah, because this part is larger than this part. I'm gonna do it slowly. I'm gonna do 4 plus cosine x less than or equal something, and at the same time, x4 plus x squared larger than or equal something. Why did I flip the sign? Because it's in the denominator.
Yeah.
You know this from school, right? When I flip the sign. Okay? Right. Give me anything larger than x4 plus cosine x.
5 cosine.
5. No. Keep it in terms of the leading term.
Okay.
So I want you to get rid of the non-leading term. Yeah? 4 plus cosine. Cosine is always between what? 1 and minus 1. So what's the maximum value of this guy?
5.
4 plus 1, right? 5. Can I use 6? Yeah, it will still, it's a fact. I can use 6. Make sense? And then here, give me something less than this. It's gonna be, forget about the root for now. Give me something less than this. It's just gonna be x4, no?
Yeah.
You have to keep the leading term. You have to keep the leading. Okay? So now, what do I conclude? 5 over x4 under the root. I put the root back. Which is equal to what?
5 over x squared.
So therefore, my integration 1 to infinity 4 plus cosine x divided by root x squared plus x4 plus x squared is less than or equal 5 over x squared from 1 to infinity. Since this converges, this will converge. But I'm missing something. Nobody noticed this. I'm missing something. This converges, right? But am I sure that this converges?
No.
Let's say this is 5. Less than 5 could be 4, 3, 2, 1,
Negative.
or negative infinity. So I need to do something here. I can bound it by 0. Why is this true? Because this is positive. This is positive. Just between 5 and 3, right? And this is root of positive plus positive is positive. The integration of any positive function is positive. If you don't understand this, you can just put it. It's fine. Okay? But this is a positive function overall. Right? So since this is convergent, and this is larger than 0, so this must converge. Yeah?
What if there was a negative?
No, we don't construct questions in this way.
Okay.
Yeah? Don't worry about it.
So it will only come in this
Yeah,
way.
don't worry. Because these are other cases, okay? More complicated. Alright?
So this is the only case that will come?
What do you mean?
Same way, so.
Yeah, if it's convergent. Let's say the thing is divergent.
If it was divergent.
No, it's fine. That's larger than infinity. Is just infinity. You don't have to do anything. Okay? Let's do one where it diverges, yeah? Let's do one where it diverges. I hope it makes sense. It's just, if you do it slowly, you will understand it. It's not something more than comparing functions. Okay? So let's do this example. Same thing, use the comparison theorem to determine if the integral converges or diverges. So let's say 2 to infinity. Let's say sine square x plus 1 divided by root of x squared plus 2x plus 7. Yeah? Okay, so again, in my head, I want to know the answer, right? What's the leading term on the top? Sine is between 0 and 1. And that is 1, right?
Yeah.
1 is yani, any trigonometric function is not a leading term. Okay, let's take that as a rule, it's fine. Okay? It doesn't lead, it oscillates, that's it. So this is the leading term, yeah? Okay, 1. What's the leading term?
X squared.
Under the root?
X.
X. So this diverges, right?
Yes.
Yes.
Because P is 1. So I'm expecting this to diverge, because I need to prove it using inequality. So let's do that. Okay, let's do that. So I take my question, and I say larger than or equal. Why did I say larger than or equal, not less than or equal? Because this side, I'm expecting it to what?
Be smaller.
Diverge. So I want to prove that I'm larger than infinity, right? Not less than infinity. Because less than infinity is what? We don't know. Less than infinity could be an infinity, or it could be what?
0.
No, a number, any number. Yeah? So I cannot have two answers. I need to have one answer for sure. Okay, so this is the correct selection of the inequality. So let's take this as a, like, if you want to take it as a rule, it's fine. If you want to prove convergence, you make your question less than and larger than 0. If you want to prove divergence, you want to make your question larger than something. And how do you know which way to go? Just do it in your head, leading terms. Do this before you start. Don't write this on the paper. Do this before you start the question. Okay? Because these questions, people mix with them in the exams and they use wrong inequality. No, we have to have something concrete to do, yeah? Okay, so this is a fraction again, right? It has to be a fraction. So the numerator has to match the inequality sign. And the denominator has to flip the inequality sign. Okay, you can forget about the square root if you want and then put it back, if it confuses you. Okay? Alright. Give me something less than sine square x plus 1.
0.
If you use 0, 0 over anything, you destroy the question. You can use 1. You can use 1. 1 is always less than this, right?
And we need
Because this is always between 0 and 1, right? Let's do it slowly. Again, sine square is between 0 and 1, right? Add 1 to both sides. Here, I use this. Make sense?
Professor, do we need the leading term, the numerator?
Yeah. Okay, now this. Give me something larger than this function. But you need to keep it in terms of the leading term. So, who's the leading term? Keep it. But if I just stopped here, is this a fact?
No.
No. So I have to deal with these guys. What do? I give them a promotion. What do I mean by this? 2x squared, 7x squared.
We score them all.
Yeah. Why? We write them all in terms of the leading term so we can what? Combine them in one term, and that becomes your p. So this becomes what? 10x squared. So I put it here. Of course under the root, don't forget, because this is a root comparison in the end. And then 1, which is equal 1 over root 10x. This diverge by p equal 1, And since this is larger than something divergent, so this must diverge. Any questions here? Is it okay? I'm not expecting you to fully understand it now, but please, when you go home or something, try to write it and put it slowly, you will understand it totally. Okay.
So, Professor, it diverges if P is less or and equal to 1?
Yes, that's the rule, right? That's the rule.
Professor, why do you do x squared plus 2x squared plus 7?
Yeah, okay, because I need this side to be larger than this side. So in your head you might think, okay, let me just do x squared. But is this true?
No.
No, it's not true. So I need to make this larger than this. The only way to do it, or the best way to do it, it's not the only way. The best way to do it is to write it as the leading term as well. Like, give them an upgrade to the leading term. So you can combine it in one term, because I need to have 1 over xp. Just a single x, right? Single x to a single power. So I need to combine. Make sense? طيب. أيمن جمالي، لين حسن، راشد، ريم يوسف، روضة عبد الله، روضة، هند موسى، غلا، عزة نجيب، تريم،
Here. Because this is equal.
شيخ محمد،
This is equal.
فارس، سيف هاني، علي إبراهيم، عوشة، عمر العايدك، عايشة منصور، مهند محسن،